Okay, this week's tutorial is on solving systems of linear equations by substitution. Okay, if we look at the first set of problems we have here, let me get something to write with. Okay, we have two equations here. I have one that says that y is equal to negative 8x minus 24. The other says that y is equal to negative 4x. Now, there are various ways of solving systems of equations. You can use calculators that graph. You can solve simultaneously. You can use addition, all sorts of different ways. There's a fairly complex method called Gaussian elimination that we will certainly not bore you with today. We're going to look at substitution because substitution is very straightforward. It is not necessarily the best way to solve all problems of this type because sometimes by substitution you can create an even more complex problem. But the ones we're going to look at in this tutorial and for the most part in your class are going to be relatively straightforward. But if we wanted to think about graphing and solving by graphing, I'm just going to do a quick sketch here. If I were to try to graph, let's say y is equal to negative 4x, that would be a line that goes through 0, 0 and has a slope of negative 4. So if I were to go down 4, let's say, and over 1, it might look something like this. Well, that's not good. Let me try another method here. It might look something like this, let's say. And since I missed that point, I'm going to go back and I'm going to make it bigger so that it's on the line. And this is just an illustration here. That would be a sketch of the line y is equal to 4x. And then if I were to sketch, say, y is equal to negative 8x minus 24, it would be another line. And it might look something like this, let's say. And the important thing to consider is that these two lines are going to cross somewhere, more than likely. And where do they cross? Well, if you look at my picture here, they cross here at this point that I've highlighted in green. And this is a very rudimentary sketch. It's not by any means meant to teach you how to solve by substitution. It is sort of just to give you a linear graph that shows what we're doing algebraically. Let's take a look at the steps to solving using substitution. The first thing we do is we recognize that y is always equal to itself. Y is always equal to itself. And if y is always equal to itself, that means that negative 4x is equal to negative 8x minus 24. And that's all they did here was they just set the two y's equal to one another. In fact, some folks will actually start off by saying y is equal to y. And then they will just go ahead and make that substitution, which is what you see here. Once we set the y's equal to one another, we want to solve for x. And if you look at this side on the right, notice that there are two terms, and one of those terms contains our variable x. So what do we do? Well, what they chose to do is they added 8x to both sides. And when they added 8x to both sides, that allowed us to zero out the negative 8x plus x, which leads us to negative 24 here on the right. And if you add 8x on the right side, you have to add 8x on the left side as well. And then if you add negative 4x plus 8x, that gives you 4x. And at that point, to get x by itself, we do the opposite of multiplying x by 4. We divide by 4. So here on both sides, we divided by 4. And then we have negative 24 divided by positive 4, which gives us negative 6 for the x value. Historically, I've noticed that students usually do a good job finding X, but they tend to get tripped up on how to find Y. But don't forget that Y is actually equal to negative 4X. So I could plug the negative 6 back in place of X. That's going to give me negative Y is equal to negative 4 times negative 6. So Y would have to be positive 24. We could have also taken the negative 6 for X, and we could have plugged it into this one here, and we would have gotten the same thing for Y. We would have gotten the positive 24 again. I would say always choose to substitute back into the simplest one, which is what they did here. I'm going to go back and try to do a much better job on that graph demonstration I tried earlier, because I've just found the right tools to do that. And I want to really do a better job trying to show what we're doing here. We said, let me change colors so we can, let's see, let's do a light blue here. We said that if we were to graph the line Y is equal to negative 4X, it would have a slope of negative 4 and pass through the origin. So it would look something like this, let's say. Let's let that be Y equals negative 4X. And then if I graphed Y is equal to negative 8X minus 24, I'll graph this one in yellow. It would have to go through a y-intercept of negative 24, probably not drawn to scale. But the point is that algebraically, we arrived at the solution negative 624 for X and Y. But now we know that those two systems will actually intersect right here at the point negative 624, which is in the second quadrant. So if you graph these lines, wherever those lines cross, that is one way of finding the solution. And we do address that in the course. But by substitution, in this case, it was, to me, it was just a lot easier to do that. Okay, let's move right along to the next exercise. And I'm not going to be as detailed this time. I don't want to utilize too much of your time. There we go. Okay, so going back to the drawing board here, I've got okay. This is actually the second problem I was trying to find for you. Here we know that negative y is equal to positive x. And we also know that negative 7x minus 5y is equal to negative 20. And what we're going to do in this case is, again, substitution. What they chose to do here is they chose to utilize the fact that x is equal to negative y. And if x is equal to negative y, they can substitute negative y straight into the second equation for x. And that's what they did here. Could they have substituted negative y in place of x? Excuse me. Could they have substituted x in place of negative y? They could have. In this case, that would have been a little more complicated. But if you go back, they simply rewrote negative 7x as negative 7 times negative y. The reason they chose to do that is so we now have one variable to work with instead of two, and that variable is y. And the rest of it is algebra. If you multiply negative 7 times negative y, you get positive y. Bring down the negative 5y and the negative 20. And then they collected like terms here. If you take 7y minus 5y, that's going to give you 2y. And then if you divide both sides by 2, you have negative 20 divided by 2. So y is actually equal to negative 10. And if y is equal to negative 10, you can go to either one of these equations and make the substitution. Obviously, this one's the easier one. So if you substitute -10 in place of y, that's going to give you minus a -10, which is a +10. So the system has a solution of x is equal to -10, excuse me, x is equal to +10, y is equal to -10. And here's our last problem for the day. I'm going to go back to the drawing board here. I've got a system of equations here. I know that x is equal to 4y minus 6. I also know that -4x plus 3y is -28. And what we're going to do here is we're going to take advantage of this fact here that x is the same thing as 4y minus 6. And we just rewrite the second equation and make that substitution for x. Instead of writing -4x, we're going to call it -4 times 4y minus 6. Just made that substitution for x. And then we just write the rest of it as it is. Notice we now have everything in terms of one variable. There's no more x's and y's to deal with in one equation. We just have the y's to work with. And the rest of it is just algebra. That's going to give me a -4 times 4y, which is -16y. -4 times -6 is +24. Just bring everything else down. Collect your like terms. We've got -16y plus 3y, which is -13y. Bring down the 24, the -28. Subtract 24 from both sides. That's going to leave us with 13y. -13y is -52. And then, of course, we don't want to know what -13y is. We want to know what 1y is. So we'll divide that -13 by -13. And that's going to give us a -52 over -13, which gives us y is equal to +4. Once we figure out that y is equal to +4, we go back up here and substitute +4 in place of this y here. And that gives us 4 times 4, which is 16 minus 6 is 10. So the x value is 10. So that means that the solution to the system is this point here at 10, 4. Those two lines are actually going to intersect in quadrant 1.